Since time immemorial, speed has been known to satiate one of man's most primal sensations, the adrenaline rush.
Everyone has a little demon in them. Mine is called speed. One thing I remember whenever I'm driving at this kind of a breakneck speed, my brakes. But why does this braking always push us forward? That and much more when we get back to the studio. Hello and welcome. I am Charlene and today we will study Newton's first law of motion. We are going to find out why things move the way they do and why some of them prefer not to move at all. We will take a look at Galileo's experiment, Newton's first law of motion, and some inertia fundas.
In the exam decoded section, learn how to multiply your exam scores.
The science behind the motion of objects fascinated two great scientists, Galileo and Newton. And in 1686, Newton established the laws governing motion of a body known as Newton's laws of motion. These laws give a precise definition of force and the relationship between force applied on a body and the state of motion acquired by it. Now let's look at something that you might have already seen a lot of times, but probably never paused to question. When a ball rolls down in a hemispherical bowl, its speed increases, and while rolling up, its speed decreases. Now, what do you think will happen if it rolls on a horizontal plane? The speed of the ball will remain constant on a horizontal plane if there is absolutely no friction between the ball and the surface of the plane. Simple things like this often intrigue great minds, which leads to great discoveries. Galileo's observation about this particular motion of an object along a hemisphere made him conclude that objects move with a constant speed when there is no force acting on them. In fact, he even did an experiment with a ball released on a smooth, frictionless inclined plane to prove his point. The ball along the inclined plane moves to the other side and reaches the same height before coming to rest momentarily and then coming back. Now let's see what happens when this inclined plane is replaced by a surface which is tilting the other side towards the horizontal. The ball has to travel through a larger distance on the other side to reach the same height, which means it will stop after traveling a larger distance. As we further go on tilting this other side towards the horizontal, the ball has to cover yet larger distances to reach the same height. And if the other side is completely horizontal, the ball will never stop, because it will never be able to reach the same height. This means its speed will not decrease and it will travel with uniform velocity on a horizontal surface. We realize that Galileo's experiment is rather elaborate, but the conclusions are simple. These conclusions are: if a body is at rest and no unbalanced force acts on it, it will remain at rest. If a body is in motion and no unbalanced force acts on it, it will continue to move in the same direction with a constant speed. And if an unbalanced force acts on a body, the body will accelerate. These conclusions together form Galileo's law of inertia, or Newton's first law of motion. So here's Newton's first law of motion that forms the basis of everything moving around us. It says, A body at rest will remain at rest, and a body in motion will remain in uniform motion unless acted upon by an unbalanced force. But why did Galileo call it law of inertia? What exactly does the term inertia mean in physics? Remember that all objects resist a change in their state of motion. So qualitatively speaking, inertia is the tendency of undisturbed bodies to stay at rest or to keep moving with the same velocity. That's why first law of motion also is known as the law of inertia. And as you must have already gathered, inertia is of two types. Inertia of motion, due to which a moving body keeps moving without any change in its velocity, and inertia of rest, due to which a body at rest remains at rest. That could perhaps explain why bodies at rest remain in bed on lazy Sunday mornings. Wonder if you ever noticed that people standing in a stationary bus tend to involuntarily lean backwards as the bus starts. What could possibly be the reason behind this strange phenomena? If you want a hint, you could log on to topperlearning.com, our website that will give you in-depth understanding of related concepts, more such questions, and crucial exam tips. After a short break, I'll explain this strange but common phenomena. I'll be back in a jiffy. You stay tuned.